Greetings, everybody. Welcome to ThingForward's IoT Labs. This is a video following one of our recent blog posts, First Steps with PlatformIO's Unified Debugger. And you can find it on our website, ThingForward.io, and then click the tech blog and you find the blog post there. So we're users and fans of PlatformIO for quite some time now, and we're using many of the features. Because they fit well in the agile workway that we like, especially when working with embedded devices. And debugging has always been some sort of special. You need an IDE that supports debugging. You need a debugger for your board, typically, or a board with onboard debugging capabilities. And typically, you need some sort of custom configuration to tie all these things together so that your debugging front end knows the debugger and knows the probe and knows the board and stuff. So very interesting that we found when we found PlatformIO announced its unified debugger, and its title it says, "Oh, it just works easier than before, easier than ever before," and a multitude of supported boards, zero configuration, and so on and so on. And so we decided to take a look at that. So within the next 15 minutes, I'm going to show some of the features of that unified debugger here online, and we're programming for many boards, and one that I have here for the debugging stuff is this one. It's from STM, and a developer board with a Cortex-M CPU and quite some peripherals. It has Wi-Fi and BLE on board, and I think sub-gigahertz as well, and much more. And you can program it using ARM embeds internal tools, for example, the online IDE or PlatformIO. And we can take a look at that here, because PlatformIO maintains a registry of all boards that it supports. So we're looking at boards and type in the name. I don't know the full name, but I know part of it, 475. Yeah, there it is. Disco L475 VG IoT. Yeah. And frameworks are embed, STM32Cube. And in the debug column, it says yes. So let's look what's behind here. This is part of PlatformIO's documentation page about the unified debugger, and it has a subsection called boards, which is quite long. So you can search for your board here. I'm going to search for mine, and here it is. Same thing, and it has a column with debugger probes, and it supports ST-Link, which is an onboard debugger on our board, and it's the default one that's supported by PlatformIO. Additionally, the Blackmagic probe and J-Link would be possible, but we're using ST-Link. And yeah, for our demo, we have a small code snippet that's at GitHub as well. So if you would like to take a look at that, go to GitHub. ThingForward PIO debugging demo is the name of the repository. Feel free to clone that and try stuff out. So I opened this in my VS Code, and VS Code is one of the IDEs that supports unified debugging. And let's arrange this here. So opening this repository in VS Code has this structure, just a simple main file, and we modified PlatformIO ini. And here is the name of the board. We're using the embed framework with some defines to compile this. And we've set the debug tool to ST-Link, which probably isn't necessary because it has been marked as being the default debug tool. So maybe I can leave this out. Okay. So let's take a quick look at the main.cpp. What it does is it defines a struct with a simple counter and a buffer where a string is rendered into using sprintf. And these resources are protected by a mutex. And there's some functions: counter init to initialize the counter, counter update locks the mutex, increments the counter, and prints some details of it into the string buffer. Mainly the current owner of the mutex that executes this code, the thread. The counter itself, counter dump, just prints this out to serial. And we have three types of threads: a counter thread, which runs the counter update and then waits a random time. a blink thread, which turns on the internal onboard LED depending on some condition on the counter in regular intervals. And this is 10 times per second. And an output thread, which just prints the buffer contents out to serial each second. And the main method starts the blink thread, the output thread, and a definable number of counter threads. So several counter threads are incrementing the counter while these two are acting upon this and making the LED blink and display something. Okay, so let's look at the debugging screen. So this is a section here called debug. When we open this, it just changes the left pane here, and it gets a new button that says debug. And you can have different debugging configurations here. I'll just choose the first one and click on it. So what it does is it executes PIO debug instead of PIO run, which compiles all that stuff that we have here in a debug sort of way, and then connects to the board via USB. That's part of the unifying thing, and opens the debug console. And there's a bunch of output here initially. So if we look at the board, we see it starts flashing red, green. Not sure if you can see that here. Yeah, it can be seen. And this means that the board is in debug mode, and it already halted at temporary breakpoint, which is the first line of main here. And we see the visuals here. That line is with a different color. And this indicates the current position where we're at. And we have this window here called stack. And it says, okay, paused on breakpoint, and we're at that point, source main.cpp line 88. Good. We could now step through this code because we have an extra button bar here that has the typical debugging capabilities. The first one is continue, so resume program, step over the next instruction, step into the next instruction if it's a function call, for example, and step into that function, step out of the function, restart everything, or stop debugging. Let's take a look where we could set a breakpoint. Let's take the counter update. So every time the counter gets updated, I would like to look into that. So I'm setting the breakpoint at line 30 and hit the resume button. It doesn't take long, and it takes me to the next breakpoint, that is here, line 30. And the call stack changed because we're not in main anymore, we're in counter update. Before that we have been in counter thread, so you can see the stack here. And one of the nice things is that this includes all the positions of the code, so you can jump at different positions in code, even code that isn't yours, that comes out of a library, for example ARM embed. So I can look at, for example, callback.h and look how they implemented that stuff, which is a nice feature. Okay, let's go back to our counter update. And in the top left, there's the variables section. And we have local variables, stack local here, global and static. Global is quite a long list. Close this and close that. So you can see a bit better. Quite a long list of everything that's defined in the global namespace. And local shows just the variables that are currently in use. And one is the counter struct variable under S. You can see, there's the counter element at 0, and the buff is empty because it has been zeroed out by the init message. And this is the mutex. Okay, now I can step through this, execute this instruction, increment the counter, and we see the counter is now 1, and it's visually indicated by this background that something has changed. And I can open the buffer character array and execute as nprintf, and now we see the contents that it has been formatted into here. Great. So sometimes it can take time to navigate through all the structures, and maybe you want to look at directly look at variables, because we can add a watch here and put in an expression here to watch, and the expression has to match the current context that we're in. So we might be allowed to say as counter is 1 or as buff at position 4, which is a 2. So we could look at arbitrary expressions here. Great, so breakpoints can be conditional. Say I want to advance in my firmware up to a certain point, and I do not want to step through all the instructions, so I can edit this breakpoint and add an expression. Break when expression evaluates to true, and I could say as counter has to be larger than 10. Good, then it's marked in a different way, and you see the watch expression here. Let's continue. And it runs and it runs and it stops again. Oh, and the counter is 11. So nice feature to bring your firmware, your program to a point depending on some form of condition. Okay, so I program in C and C++, definitely not assembly. But if you're into assembly language, then the disassembly, switch to disassembly functionality might be interesting to you, because it allows you to instantly look at the assembler code of that function that you're in, and it switches the whole perspective to it. So if I now say step over, it steps over the assembly instructions. And I'm allowed to, for example, look at processor registers and yeah, to see what the code is doing here. So very interesting if you either know assembly language or are willing to learn this, and then this function might be quite helpful to you. So I'm switching back to code again. And we can close this. Debugging can also be helpful whenever you need to debug code that talks to peripherals or library stuff that deals with peripherals. And this view here has a separate peripherals section. So let's say I'm deleting this breakpoint and putting a breakpoint at another thread. And we have the blink thread that turns on the LED every time the counter is divisible by 2. No, other way around. It turns off the LED when it's divisible by 2. When it's even, when it's odd, the LED turns on. And let's break here and resume. And it stops here again. So LED is a global variable, an instance of the class digitalout. And I can, of course, look at that variable. It's in the global section, so I have to search for it. LED. Can explore the structure a bit. It says GPIO public. Oh yeah, pin PA5. Now what does that mean? We can take a look at the peripheral section and find quite many peripheral, say, objects here, I2C or RTC, random number generator, SPI, fancy stuff, as well as GPIO. And GPIO is divided into several sort of banks, and there's a GPIO-A, and it has fields for input and output, I'd say. And the 5th position is set to 1. Now that's pin A5. It's from GPIO-A, 5th element. And we can execute that. Oh yeah, and it turned to 0. Might turn to 1 later, depending on the state that we're in. Yeah, it turns back to 1. So if you know much about that internal peripheral structure, then you're able to look at all the internals here. And not to forget, you can look at memory. So if we see variables that point to some form of memory structure, we can debug the memory itself. Let's add a breakpoint, no, not a breakpoint, a memory position here. And it asks me prefix for the position, prefix with OX and hexadecimal format. And I give it here. That's just one of the random objects that we have. And it asks me for a length. Now let's say 56 bytes, and it opens the memory dump. So nice way to look at memory if you know what it's displaying. Okay, short overview of the PlatformIO Unified Debugger. Many things to explore and a good way to understand your firmware debugging through it. It has been fun. So thanks for watching.